given this function, find its first derivative, find the equation of the tangent line to that curve at this point where x equals pi over 3. And I'm assuming that this 11 is really like double prime. You don't want to find the 11th derivative, you want to find the second derivative. Although, with little work, you could find the 11th derivative because after you find the first 3 or 4 derivatives, you will see a pattern. But anyway, how do you find f prime of x? Well, we're going to take the constant 1/2 times the derivative of this. The derivative of the cosine of anything is the opposite of the sine of the same anything. But then we have to multiply by the derivative of the anything, or the inside chain rule. That's a 2. And if we collect factors at the beginning, we get the 2 times 1/2 is 1, so we get negative sine of 2x. That's your formula for the first derivative. To write the equation of the tangent line, we need to know the x and y coordinate of the point on the graph. That's what we did here. Calculate the y coordinate. F of pi over 3 means put pi over 3 right there. So the cosine of 2 pi over 3, you could use the unit circle. You could realize that this is 2 pi over 3. We've got a 30, 60, 90 right triangle. The cosine is negative 1/2. So the y coordinate of the point on the graph is at negative 1/4. And if we find f prime of pi over 3, we'll find the slope of the tangent line at that point. So put pi over 3 in here. And the opposite of the sine of 2 pi over 3 is negative radical 3 over 2. Okay, so now for part B to finish up, we know a point and we know the slope. So we'll use point slope. Y minus y sub 1, y plus a fourth, equals the slope, negative radical 3 over 2, times x minus pi over 3. The quantity, x minus pi over 3. And finally, to find the second derivative, we're going to take the opposite of whatever the derivative of the sine of 2x is. The derivative of the sine of anything is the cosine of the anything times the derivative of the inside. So there's your second derivative right there. I'm sharing my screen right now. Oh, I wanted to go back to here, show you here's a graph from Desmos depicting what's going on. This red curve is the original function. The light green dashed curve is the derivative, graph of the derivative, and there's the tangent line at pi over 3, negative 1/4. If I go here, you might want to take a look at this graph later to see some stuff you can do on Desmos, but here's the tangent line at any given point on the original function. Okay, so I'm moving that point along. There's the one that coincides with the tangent line at pi over 3. Okay, there you go. Hope that helped. If you have any questions, post a comment.